Hello, good morning everyone. So my name is Giuseppe Pascale and I'm from Opera TV. So before I start to talk about my presentation, allow me just to say a few words about what Opera does. So Opera has been in the browser maker for more than 20 years. And in Opera TV, what we do is to provide the browser as a rendering engine, basically to power the OTT experience on many smart TV and set-top boxes. So we like to call ourselves OTT enablers, because what we do is we allow all these connected devices to really run services like YouTube, like Spotify, like BBC iPlayer, and so on. And we are on a variety of devices, including Sony, Hisense, TVs or TCL, as well as set-top boxes from a variety of vendors like TiVo and so on. In this presentation, I want to talk about how ATSC 3 is bringing together two worlds: the world of broadcasting, which is a reliable and scalable way to delivering content to users, and the world of OTT, the world of the internet, that is bringing together, bringing to the user personalization, interactivity, and the ability to get content everywhere. But before we talk about ATSC 3, I just want to talk about why there was a need to bring a new standard, a new version of ATSC 3. We all, I think, agree that the way users consume content has changed a lot in the last years, right? So in the last decades. When ATSC 1 was designed, the TV was mostly, let's say, a passive medium that you could consume in your home at a scheduled time. But TV today, it's a very different experience. Users want to be able to watch content everywhere, on any device they own, if they are in the home or if they are on the go. And also, it's not anymore like a static scheduled experience. It's an interactive experience. You want to be able to personalize to your taste and to where you are. And the internet companies have been able to capture these needs and address them with services that you can find on any device, and the user as well has been buying devices like these OTT streaming boxes that can connect to their TV and finally make them interactive and having that content that they need available at any time. We've seen also an increase in people cutting the cord, so relying for their local needs just on free-to-air TV, and then combining that with an OTT box or anyway an SVOD service for their other content needs. So there is clearly an opportunity here to combine the broadcast stream with the OTT streams into one platform, and that's what ATSC 3 is doing, right? So it's bringing really technology that can finally meet the needs of the consumer of the 21st century. So, what is ATSC 3? ATSC 3 is not one spec, but it's more a suite of specs that goes from the physical layer up to the application layer. So it's a complete redesign of the architecture, and that's why it's not backward compatible with the previous version of the spec. Of course, talking about everything in ATSC 3 will take a long time, so we'll focus this presentation just on the higher level of the stack, the application level. One important thing to say about ATSC 3 is that it's a hybrid architecture. So it relies, of course, on the broadcast as well, but it has an internet connection. So an ATSC device is a device that is able to fetch content both from broadcast, from the airwaves, but also from your broadband connection. And both are based on IP, so it's a complete IP-based solution. So what you can do once you have a broadcast and broadband solution? First of all, the traditional way of consuming TV. So you can have your TV and getting the signal and getting an audio-video service as you are used today. But since you have a broadband connection, you can also imagine to get some additional content. I don't know, some additional audio languages, some alternative camera angle directly from the broadband connection. So that allow people to, broadcasters to save on bandwidth, for example, and to deliver more personalization to the content, also if that signal doesn't need to go to every TV. So the user is finally able to select what they want to enhance their viewer experience while they are getting the main service from the TV, which is the same for everyone. But since we have, once a two-way connection, we can also have interactivity. So ATSC3 buses have an interactive environment, and then inside the device, you can finally have some interactive way of, some way to interact with the service. It could be anything from weather alerts to quiz so that the user can interact with the show, but also a fully fledged portal where I can watch the catch-up of all the content for that channel in the last 7 days, or in the last 30 days, and so on. So really there is no limit in what you can do, and the technology here is HTML5, so you can have the same power that you have today on the web. To be clear, the architecture is such that the interactivity can also be delivered over broadcast. Of course, it's a little bit limited because in terms of what you can do being a one-way medium. But one use case, for example, is for people that have one connected device, but they haven't connected it, which can be an issue in some cases, to use this interactivity to promote to them that by connecting their device, they're going to be able to access additional content that they wouldn't otherwise, which is with just a one-way service. What is also interesting is that with ATSC, you can even deliver the full service over broadband. So you could, in theory, build basically an HTML5 application, which is your channel, and is delivered to the TV as such. So and that could be useful in different cases. For example, if you are in an area where the reception, for whatever reason, is not good for broadcast, you could switch to broadband and maybe go back once the signal is powerful enough, especially if you are on the go and you have spots where there is no broadcast coverage. So in essence, the screen becomes a web page. And through that web page, through the application running that web page, you can achieve two things. You can complement the main viewing experience, or you can actually control it fully. And so having an app that is able to fetch content from the broadband, content from the broadcast, combining together in an interactive service. So why HTML5 was chosen as a runtime environment and not something else? Well, one of the reasons is that it's already widely used and already widely supported out there in many devices, especially if we look at the OTT environment, so the smart TV space and set-top boxes, which is fragmented and is not like the mobile space. Most, if not all, platforms support already HTML5 applications. So it was a natural choice to use that as a runtime environment also for ATSC3. And it's already widely used today by OTT providers. So if you're using, I don't know, the BBC iPlayer in the UK or YouTube everywhere in the world on a TV, you may not know, but you're actually interacting with what is a web application, an HTML5 application. And that's the same for many other OTT providers. So the advantage here, once again, is that you can reuse technology you are already used to in this space, right? And reuse technology, you reuse knowledge, and so on. When it comes to media streaming, once again, ATSC3 rely on well-established technology, in particular MPEG-Dash. The new thing here is that on top of using MPEG-Dash for streaming, like we're used on the web, you can now use MPEG-Dash also for broadcast delivery. In particular, a protocol called Route is used to deliver the MPEG-Dash fragments to through broadcast to the device. Once they reach the device, the player is able then to combine the two if he wants to, so the broadcast segments and the broadband segments, and render them on the screen. Once again, this gives flexibility to choosing what is the best medium for that particular scenario or business case you want to achieve. One thing also important to notice here is that you have two types of players defined in the spec. You can have a native player, so the one embedded on the TV at let's say at an operating system level, but you can also have an application player, so one written once again with web technology. The advantage of that is that you don't need then, if you want to adapt or evolve your player, you don't need to rely on the manufacturer to update the functionality of the player on the TV or on the set-top box. So you have more flexibility as a broadcaster to control that experience and maybe to evolve it, because of course in the next years this standard will evolve and you want to be able maybe to introduce new features. So by having a native player written in JavaScript and HTML technology, then you are more flexible in terms of both of UI, user experience, but as well as in terms of protocols. One thing you can do in ATSC3 is also to download content on the device. And you can do that through broadcast and through broadband. Once that content is downloaded and available on the device, you can then play it back using the media player that you have. Once again, either the native or the application one. One use case where this might be particularly important is ad insertion. So with ATSC3, you can finally have targeted, customized ad insertion. So by starting from the same stream, you can then replace an ad to customize it and to target it to the user or to the household. This is achieved once again using Dash. So basically, if you have a Dash stream that is coming to the device can decide to just play whatever is in there in terms of advertising, or it can recognize that there is an ad opportunity and implement some logic once again in the application and replace that ad, maybe prefetch it, an alternative ad, and ask the player to basically replace the main ad that is in the stream with this new personalized, customized ad for that particular household. Going a little bit down in the software stack, when it comes to video encoding, ATSC3 rely on HEVC, and that brings a lot of functionalities to the broadcast and broadband delivery of video. I mean, probably the most important one are 4K UHD content and high dynamic range. But of course, there are a lot of other functionalities that can be enabled thanks to to HEVC, and also, I mean, HEVC being like a more, brings also a little bit more performance and allow to better use the spectrum and the bandwidth you have thanks to the increased compression. When it comes to audio, also here, ATSC3 tried to introduce some elements of personalization for the user. And so it defines 3 different audio models. One is the traditional channel-based models, where you now can go up to 22 channels. But there is also a concept of object-based models, so you can basically describe a sound in space, and that sound, of course, can move into the space, or a scene-based model, where you can describe basically the sound for that particular scene or a set of scenes. All of these then will, of course, need to be combined from the device and then adapted out to whatever audio device or reproduction device you have on your device. But the advantage of these models, especially the object and scene model, is that now the user can also personalize their audio experience. For example, they can decide to increase the volume of the dialogues and maybe reduce the volume of, other sounds in the scene. And that can be used also very useful for accessibility reasons, right? So if someone has problem hearing, they can increase the dialogue and remove any other sound. So all of this is described as a framework, and then there could be different formats that implement that framework, and one is AC4, which is probably going to be used in North America, and the other is MPEG-H Part 2, which is for usage, I believe, in South Korea. Finally, when it comes to caption and subtitles, ATSC3 relies once again on already used standards for OTT delivery. In particular, it's based on TTML technology, so it's an XML format standardized by the W3C. There are 2 profiles defined in the spec. One is based on text, so basically on XML, and then the rendering engine, being it the native player or the browser, will need to render that text to the screen, or you can have an image-based profile where the subtitles are just PNG formats. Finally, one other feature that ATSC3 introduced is the possibility of having an interaction between the first screen and what's called a companion screen. So now in ATSC3, any device can be used to consume content. So what is a primary screen is basically anything, right? It can be the TV, it can be a smartphone, it can be a tablet. But I would say the most common requirement when it comes to companion screen, which is whatever else, whatever other device you have that to complement your experience on the first screen. So I was saying the most common scenario is when you have the main content on the TV, and then maybe you want to have additional content, being additional audio video content, but also interactive content on another device. Maybe not to disrupt the, let's say, the experience on the main screen, right? So you could imagine that while everyone is watching the same primary screen, you want to have some complementary information on your tablet or in your smartphone, or maybe even some additional audio track or some subtitles on this companion device. All of this is based on technology that have been already used in the industry, both in the ODT world, but also in the hybrid world. So one technology is called Dial, is a technology that, for example, is used by YouTube or Netflix when you're casting your video from your YouTube app to the screen. That's based on the Dial protocol. And a similar technology is also used in Europe by HBTV to achieve basically the same thing. So the ability to connect your secondary device to the TV or vice versa, and to have these two devices interact. If you want to see all of this in action, if you go to the North Hall, we have been cooperating with Pilot, which is the research arm of NAB, to show a demo of some of this functionality. So if you go there, you can see all of this, or some of these at least, in action. So in conclusion, I think ATSC3 really introduced a lot of possibility, both in terms of for the end user, but also for broadcasters and advertisers. Now the spec have been finalized in the last months. Now it's up to the industry, of course, to take this to the next level, to integrate into the devices and also to the broadcaster to start to leverage these new functionalities. So that's all I had for now. If you have any question, I'm happy to, after this presentation, to just, I'm gonna be here for a while and then I can take questions if you want. Thanks.